Hello, so today I will talk about chapter 11.2, which is about slope fields. So slope fields is a tool for us to kind of guess what the shape of the graph will be according to the initial condition. So the question right here is telling us to match the equation and the graph, the slope fields. So they gave us six options of equations and 6 graphs right here. So as you can see, they're all different. They have multiple these little tiny lines with different slopes. So one way to match the equations and slope fields is plugging in some values for x or y and get the y derivative, and the value of y derivative will be indicated as these little lines. So these little lines are the slope at that point. So but putting all the like substituting any values takes so long time, so let's be a little smarter. So here we can see there are six equations, but actually there's only 3 types of equations. So one is y prime equals equation that's only involving y, variable y, and one is y prime equals only involving x variable, and one is y prime equals involving both x and y. So we can find some property of these, the characteristic. So if we plug any x value, it won't change because there's only y value. So the only slope changes according to the y value. So when you look at the graph, only slopes that will change is when you slide up and down. So all the horizontal slopes will be the same because it doesn't get the influence of x value. So this will happen to the equation that only involves y. So the equation only involves x will be the opposite. So vertically it will be the same slopes, but if you slide left or right, it will all differ like this. And this case, when it involves both x and y, they can vary anyway. So it's impossible to find a horizontal or vertical line that has same slopes every point. So let's use these 3 characteristics we just found, so it's easier for us. So right here we have 1 plus y squared, that's a. So because it only involves y, we know that the slopes in each horizontal line will be the same. So 1 can be option, 2 can be, but 3, 4 cannot be the option, and 6 too. So we can eliminate 3, 4, and 6. And then now what we have to do is just plug in values and see. So if we plug 0 in, it will be 1, which will be this shape. This is 1. So most likely 2, because the slope here is too low. And then 5, which is another option, is too stiff. So only option for A will be 2. So A equals 2. So using this process, we can eliminate mostly half of the options, and then we can start plugging in. So now it only involves x, which means vertically it won't change. So 2 is out, vertically it changes, so 1 is out, 3 is out because it vertically changes too. So only choice will be 4. So 4 and 6. But the graph was y prime equals x. So when x equals 0, it will be 0. So 4, 6, there's most likely 0. But if you look at the trend here, it's going up and it's like oscillating. But here, it's going up and up and up. So x1 equals 1, x2, the slope equals 2, x3, slope equals 3. And it seems like it's matching the equation. So 6 will be for the b, y prime equals x. So like this, you can find it. So we did both type, y involving type and x involving type. So now let's just try e. E is both involving x and y variables. So this one will stick up pretty much. So here, these are horizontally all same, right? So like these are all same. Even though you slide left to right or right to left, they're all same. And here is all same too. So these are using, you can say that these two are only involving y. And here it's only differing by vertical lines. So each vertical line slopes are all same. So we can say this is x. This is only involving x value, x variable. And here too is only involving x. And then here is only involving y, because it's horizontally same. So 3. If you slide down, it seems same, but actually the slope changes. And when you slide left to right horizontally, it also changes too. So neither way it doesn't work. So this means that it's both involving x and y. So using this method, you can it's much easier way to figure out and match the given equations and the slope fields. Thank you.